about exponential function. We have cos, we have sine, and we have tan. I'm not talking about tan yet. Let's talk about cos and sine. This is the expression for hyperbolic cosine, that is cos. And this one is for hyperbolic sine, sine. Now, let's differentiate the first one. E raised to power x plus minus 1 into e raised to power minus x. Over 2. You can see, and that's going to give me e raised to power x minus e raised to power minus x over 2. So, compare this one and that of hyperbolic sine. You can see it's the same thing. So, therefore, this is another standard result. It's not, you can see that those results are not hard. The results are not hard to derive. So, just try to learn the ones you can learn, but know how to derive them. It's very easy and cheap. Now, let's derive that of sine. So you can see that this thing is the same thing as cos. Therefore, differentiation of sine x produces cos x. So I hope you are following. It's very, very easy. Just follow. And then take notes when you think you should. You know the other time we got the differential of e raised to power x. And later on we got that of plane x. So in the same vein, I want us to look at inverse of trigonometry, where we can talk about sine minus 1x. You understand? Inverse of trigonometry. The other one, sec, cosec, cot. Those are reciprocal. Those are the reciprocal. For this one, we are trying to look at the inverse of trigonometry. What are we talking about? We are talking about y equals to sine minus 1x. Y equals, you can see, y equals sine minus 1x. Now, let's start with this one. We have y equals sine minus 1x. Therefore, x equals to sine y. Dx dy is equal to cos y. 1 minus sine square y square root. X equals to sine y is equal to 1 minus x square or root. Therefore, dy dx is equal to 1 over square root of 1 minus x squared. You can see it's very simple and straightforward. If y equals, let's look at that of arc sine, arc cos, y equals arc cos x. You can now say x equals to cos y. Dx dy is equal to minus sine y. This is equal to minus into root of 1 minus cos square y. And from here we know that cos y is equal to x. This is equal to minus 1 minus x squared root. Therefore, dy dx is equal to minus 1 over square root 1 minus x squared. That of sine is positive. That of cosine is negative. You can see how beautiful it is. Now let's look at that of tan. Y equals arc tan x. trigonometric, what do we call it then? Now, we know that tan y is equal to x. So dx dy is equal to 1 plus x squared. Therefore, dy dx is equal to 1 over 1 plus x squared. You can see. Before I conclude, I just like us to take note of some things. Now, let's quickly look into this. In this situation, please, f is a function of x. So that's why I say application of chain rule. This one will be the function of x. So if you are going to apply that, we are going to make this one like, you know now, nf raised to the power n minus 1. That will be there. Then we will now differentiate f with respect to x. Remember. Now, for this one too, we are going to have this one to be cos f. Then, df dx. This one will be minus sin f. Df dx. So that's why we come to the front, please. It will multiply the f here. It's coming later on to the, we put it here. This one. This one is going to be e raised to the power f and then df dx. This one, I was trying to, describe it before, but I believe it is better to do that now. This one is going to be 1 over f. Now you now differentiate f with respect to x. Df dx. That's what I was trying to explain the other time. That the differential will be up and the actual function will be under as denominator. So I think it is better explained here now. Here's the differentiation of tan x. Tan x is equal to e raised to the power x minus e raised to the power minus x over e raised to the power x plus e raised to the power minus x. That is sin x over cos x. Just like in the normal trigonometry. So this one is the exponential aspect. Now if we want to differentiate this, we use quotient rule for this. We have known that this one is the differential of this and this one is the differential of this. So d dx tan x is equal to cos x and x, sorry, cos x minus sin x, and this one again is sin x divided by cos x squared. And what does that give us? This is right here. And that's going to give us cos square x minus sin square x divided by cos square x. Now, if we do this, we realize that the numerator is equal to 1. And that is going to give us, let's say, e raised to the power x plus e raised to the power minus x all squared minus e raised to the power x minus e raised to the power minus x all squared. This one is over 2 now. Over 2. Divided by cos square x. You can see that this is the difference of 2 squares. And that's going to give us e raised to the power x plus e raised to the power minus x plus e raised to the power x minus e raised to the power minus x now this one will now be e raised to the power x plus e raised to the power minus x minus e raised to power x plus e raised to power minus x over cos square x. By the time you look at this one and this one will cancel out. And I'm going to have 2e raised to power x. And this one here. Yeah. Into 2e raised to power minus x. This one over 4. Now, I now divide this one again by cos square x. So you can see that this one and this one will cancel out. E raised to power x times e raised to power minus x will be equal to 1. So at the end of the day, I'm going to have 1 over cos square x. So that's the differentiation of tan hx. Please take note of this as well. Now, let's talk about logarithmic differentiation. This is the trump of my technique in differentiation. I love this. It makes the job easy. Requires, makes difficult thinking. Makes it very simple. Like if you have products, or functions, with logarithmic differentiation, you can make it very simple for yourself, and you get your answer with one step. Let's look at something like this. If you have y equals u, v, w, and the three of them are functions of x, that is u, v, w are functions of x. By the rules of logarithm, in y, remember, will be equal to ln u plus ln v plus ln w. You remember? Now, from products to sum, and we have made it ln each. So, we have said something before. When you have a function like this, ln f, when you want to differentiate it, you are going to have 1 over f. Are you seeing? D df, f df dx. You can see. So this makes it very, very easy. I will show you 2 steps now. That makes it now very clear. We can now say 1 over y dy dx is equal to 1 over v dv dx plus, 1 over u, since we started with u, 1 over u du dx plus 1 over v dv dx plus 1 over w dw dx. It makes the job very, very easy. Now, if we make df dx, we represent it like this. And we represent du dx as dv dx. Just like saying complements, how we represent complements instead. And dw dx as. So this equation now becomes y over y is equal to v complement over v plus, I start with v is equal to u complement over u plus v complement over v plus w complement over w. At the end of the day, all you just need to do is you leave this one here and you just do the normal way you handle fractions. That's how you get your answer. It becomes very, very easy. I will give you an example now. So this one will now become, now be equal to let me just leave it like this. can see. Makes the job very easy. And when I show you an example or two now, you will see. You always want to use it. Even you prefer it to this product rule, quotient rule. But it depends on how you are practiced with it. Now, look at this. If I expand it, I can use quotient rule. I can use a product rule, depending. But if I use this logarithmic differentiation, it makes it very easy. You can try it. After I use logarithmic differentiation, you can practice, try quotient and product rule to confirm the results. In this instance, I have y equals 3x plus 1 bracket multiplied by cos x divided by e raised to power 2x. Now, what do I have now? I can now express it like this. In y equals ln 3x plus 1 plus ln cos x minus ln e raised to power 2x. You can see the job becomes very easy. Now, from what we have now, I can now say y over y, or let me put it like this. 1 over y dy dx is equal to this one. 3 over 3x plus 1 plus, when you differentiate this, it's going to give you minus sign. Minus sign x over cos x. And this one, what does it give? E raised to power 2x over, 2 e raised to power 2x over e raised to power 2x. You can see, instead of all this expansion, factorization I would have gone through. Now, I can now say dy dx is equal to y. And what is y? 3x plus 1 into cos x over e raised to power 2x into, look at this, 3 over 3x plus 1 minus sin x, okay, let me put it like this, minus tan x minus 2. At least, I think this is the easiest, this is the best way to do it. So, you can see that I don't even need to do unnecessary expansion, factorization, and all this stuff. So later on, when we have some exercise, you will see how we apply it more. Please, at this juncture, I'm seeking for your assistance in giving me questions that you feel like you will want us to work on. And at the same time, kindly subscribe to Abut, share, make comments, like. Everything that you know you will do to encourage us, please do. Let many people to know. And if you haven't subscribed, subscribe so that as soon as any lecture lands, you'll be part of the first set of people to be alerted. Please, we appreciate your support from the past, and whatever way you think that this class should be handled, please let us know in the comment section. And anything you feel like, maybe you have a material you think we should have, you can send it to us through the description. We see the channel to do that via the description. Thank you very much. Now let's work on inverse hyperbolic function. Inverse hyperbolic function. Now this is like when we have y equals half sine x. Therefore x will be equal to sine y. And we know that if we differentiate this one, it's going to give us cos y. So dx dy is cos y. And we noticed before that cos square y, okay, minus sine square y is equal to 1. We can then say that cos square y is equal to 1 plus sine square y. So cos y is equal to square root of 1 plus sine square y. And we know that y is equal to x. Therefore, cos y is equal to the x dy, which is equal to square root of 1 plus sine square y. You get it? Which is square root of 1 plus x squared. So dy dx is equal to 1 over root of 1 plus x squared. So you can see the similarity with that of the trigonometry. Only that one has negative, minus sign. Now let's look at that of cos. Y equals a cos x. Therefore, x is equal to cos y. The x dy will be, but we know that sin y cos square y minus sin square y is equal to 1. So, cos square y minus 1. You get that? And we know that cos is x. So it is x squared minus 1. So sin y is equal to square root of x squared minus 1. Yep. Therefore, dy dx is equal to 1 over square root x squared minus 1. Simple and straightforward. Now let's look at tan. So therefore, x is equal to tan y. And we have discovered that when we differentiate this, it's going to give us 1 over cos square. So this one is going to x. The x dy is going to give me 1 over cos square y. If you can also sec square y. 1 minus. So you see, it is now very, very interesting. You can confirm this. You can confirm these results. Or if there is time, I can do that. So, the x dy is equal to 1 minus, sin x square y is x squared. You can see. So it's very, very easy and simple from here. So we can now say dy dx is equal to 1 over 1 minus x squared for tan x tan x. So from here, we are still in the basics of differentiation. Very soon we'll go into application before we go into integration. I'd like you to list out all the standard results we have derived and try to learn them or how to derive them in case you are boxed in the corner. Thank you very much. By next lecture, we will do some exercises and note where it can be applied. Thank you for your patience and thank you for the support you have been giving me. I really appreciate you all. God bless you. Till next time, STEM Cafe. Keep watching.